All right, good afternoon, folks. So today's our second lecture on design patterns, and I really only have one to talk about today. It can be a little bit confusing. That's why I've only sort of chosen one to mess with. The author of the game programming patterns book that I've talked a lot about does have sort of a full chapter on this pattern that we're going to use today. I'm going to show you sort of a way that I've gotten used to implementing it. It's not exactly the same as the way that he does in the book, so you'll have sort of a couple of competing implementations. There are lots of ways that you can implement this thing that I'm going to show you today. To me, I like this particular version, but if you go online and you look up, how to create this state pattern in Unity or in Java or in whatever language and editor and engine you're using, there's probably different implementations for each one, and there might be one or more that you like better than what I'm going to show you today. But I want to get the fundamental concepts across so you can hopefully see how it can be useful. And I think I'm going to steal one of the game programming patterns books sort of examples as to the mess that you could get yourself into if you don't have one of these this sort of state pattern that we're going to talk about. In addition, I know Joey just asked this question, but if you want to start up just an instance of Unity, the only thing I've done to this project, this is one that had just some leftover stuff. I think it has like a particle system or something in it. If you want to just create a quick script, I just name this one state, and it's just the default script. So we will come back to this later. We're not doing anything special in this Unity project. We're just going to be printing stuff out to the console to show how this state pattern actually works. All right, so essentially, if you look up the sort of state pattern and sort of get its definition, like our singleton pattern, we sort of have had a definition of what the singleton was supposed to do. The state pattern essentially says this: you allow an object to alter its behavior when its internal state changes. From the outside, so if you don't think about the internal state of an object, the outside will make it appear that the object is changing its class over time, which to me is actually really cool. Like if you're running your program, you're running some sort of whatever it is, a Java program, a Unity program, it doesn't matter. C++ doesn't matter. If you have a state pattern here like this, you program up your own state pattern, it will look like wherever you use the state, this sort of state object, wherever you use it, it will look like it changes. That object changes its class depending on what's happening in your program. So we will see that today when we go in and code this up. It's not going to be anything revolutionary in the way that we do it, but we're going to take the state pattern and we're going to use it in our next two games. So we are going to so next week we're going to start on a sort of Flappy Bird clone type game. That it's relatively easy. We're only spending a week on it, but this is a chance to use some of these patterns to think about how we actually implement them in a real game rather than just sort of think about them at that sort of high sort of academic level sort of thing. So Flappy Bird game is easy. There are thousands of tutorials online on how to make Flappy Bird in whatever game engine you want to do, but most of them keep it very simple because it is sort of a beginner type project. And this is where I wanted to inject some of the stuff that we've been learning, like some design patterns, into an actual project before we then take it to the next level and incorporate it a little bit more deeply into our third game. So the fundamental concept that we're going to use for the state pattern is the finite state machine. If you've taken any sort of AI classes, I know that Professor Folajimi offered a game AI class over the summer. So if any of you were there for that, you probably talked about finite state machines. It's sort of a fundamental aspect of AI. There are ways to implement it in pretty much every single language. You can do it with something as simple as an enum, or something a bit more complicated, which is what we're going to do today, using classes. We are in our third game going to actually determine some AI behavior based on a finite state machine, and I'll come back to that at the end of the lecture today to at least give you a description of how you could take the state machine that we're going to make today and potentially do some AI behavior with it. And then in the third game, we will actually do it. We'll have a couple of different types of enemies, and we'll have a boss enemy that its behavior will appear to change its class as things happen, which is what part of this sort of state pattern sort of thing actually does. So we'll use the finite state machine for some AI behavior. And again, the game programming patterns book has a great chapter on the state pattern. So that's another one that if you've sort of gotten past or if you looked at any of the singleton stuff, if you want to go a little bit deeper into something that's really useful for games, the state pattern is sort of the next one to go for on that. If you don't want to read the whole book, the singleton and the state pattern are actually really, really cool to look at in that book. All right, so let's say you're making a game and you're working on the player class. And of course, you need to handle input in some way. You want the player to do something when keys are pressed or whatever. So let's say, I don't know, let's say you're using a controller or something. I don't have this sort of Unity specific, so you're not necessarily going to be able to take this and put it directly into Unity, but it should be sort of simple enough to understand what is happening in this code without being sort of too language specific. So we have some function, handle input. It takes in, whatever the input happens to be. If that is equal to the key B, so probably a controller or something, you're pressing the B key on an Xbox controller or something. If the input's B, and if you're not jumping, so that's my is jumping here. If the input's B and you're not jumping, then let's jump. So set the is jumping to true, so you now are jumping. And then you do whatever jump code that is. There might be an animation, there might be a sound, there might be a particle system that happens, whatever jumping code you need to do. So again, if you press B and you're not already jumping, then set a jumping flag to true and then do a jump. This is a way to handle state in a game. Your character would be in a jumping state or not in a jumping state, depending on our flag, our is jumping Boolean. That's the simplest way to handle state, a series of Booleans. So this isn't too bad. But as soon as you start adding more possibilities, this starts to get a little bit worse with every little possible state you add. So you might have, and we'll get to it here in a second, but you might have a jumping state like we have, and then you might have a crouching state. And you might be able to attack while you're jumping, but not attack while you are crouching. So you add these little flags in for is jumping, is crouching, is attacking, and all of a sudden you end up with more or less a mess. So let's say we add some other stuff in here. Let's say we say else if the input is down, so we're pressing down, whatever. And we're not jumping, then we can set the graphics to duck or crouch or something. Otherwise, if the input is not down, then we say stand. We display our graphics stand, and maybe we have another flag associated with that. Same thing with our sort of ducking or crouching. We set a flag to it. All of a sudden, we start to get a whole bunch of else ifs, and these are all going to start depending on what the character's doing, those Boolean sort of flags that we're creating. And so hopefully at this point, seeing this code sort of expand, hopefully you can sort of understand that as you add more and more and more possibilities, so we think of things like a wall climb and a wall jump and a wall attack and maybe a jumping attack, and what all of these possibilities and all these flags that you end up needing to check, it's going to start getting a bit ridiculous. You're going to have a gigantic mess of if-else statements, and you're not going to have any idea what's going on, especially after, a week after writing it, you're going to come back to it and go like, well, it works, so, I won't mess with it. But then you want to add a new ability in or a new graphic in for sort of something that you're doing, a wall climb or something. Now you've got to dig into the code and figure out, all right, where do I need to fix all of this and all of these flags, and what flags do I need to check? And it's just a constant cycle of changing your code, realizing you missed something, changing it again, you still miss something, changing it again, it's something else this time. So it starts to get a bit ridiculous. This is where state comes in. This is sort of the motivation for having a more structured way to define what state a character or an enemy or the entire game itself is in at any given moment. So that's where this finite state machine comes in. So this code, it's not very extensible. You can do it, but it's a pain. Every time you add something new, you're going to have to change a lot of code, which sucks. It's bad. That's more time for errors. You got to code a lot of stuff up. You got to change a lot of things. More errors are going to creep in. And if your code starts to get where you need to add lots and lots of features, especially, let's say you're working somewhere at a game dev studio and they're like, hey, we need this feature added. We need all these features added in a week. Do it. And then you realize that it's going to take you way longer than a week to put it in a test. Then that does become a major problem. So this is where the finite state machine comes in. So this is the image from the game programming patterns book. And it's basically the same sort of thing that we just saw. So it's sort of a diagram of the possibilities for what the character can do. So if we start with standing, if you press down, you're now in a ducking state. If you release down, you're back to the standing state. If you press B, you're in a jumping state. If you're in the jumping state and you press down, then maybe you go into a diving state or whatever, a jumping attack sort of state, like a dive attack or something. This is the idea. Even if you have a complicated set of states, diagramming it out can help you understand how they're related. So if I'm in a jumping state and I press down, there's no way I go into a ducking state. The only thing I can do while I'm jumping is go dive while I press down. Some other condition will bring us back to the standing state, like landing on the ground, for instance, would probably take you back to standing. So drawing this sort of diagram can be very helpful, especially because we're going to use this as our basis for coding up our state machine as well. So you can apply this not just to the player, but to bosses, for example. So say you're playing, I don't know, say you're playing one of the Dark Souls games, or you're playing Monster Hunter or something, and each of these bosses or monsters, they're going to have different states that they're in. And I'm not just talking like an enraged state or like a phase 2 state, but even their regular moves could just be states. If the player is very close to the monster or to the boss, that could be a trigger for doing a specific kind of attack. Or that could be a trigger for doing a specific kind of motion. So you can imagine states being things like a close attack, like a melee attack, or a ranged attack could be another state. And that could depend on where the player is located. So hopefully, just based on that description and sort of the picture you see here, hopefully you can imagine drawing up a diagram like this for a boss that you've encountered in sort of any sort of a video game. Especially if you played the boss sort of enough, you've beaten the boss enough to understand what their states are, and sort of what they do, what their moves are. In essence, they're just states. And depending on whichever one they do depends on some sort of input, whether that's player input or whether that's some sort of other AI input that goes into choosing what they do. So that's the gist of the finite state machine. And then, of course, by extension, the state pattern. Because a finite state machine is what we will implement to achieve the state pattern. Essentially this. You have a fixed number of states that the machine can be in. The machine can never be in more than one state at any given moment. You can only be in one state at any given moment while your application is running. So standing, jumping, ducking, melee attack, ranged attack, whatever. Like that. So you can't stand and jump at the same time, basically. A sequence of events is sent in to the machine. So something happens where you get information into the machine, like a button press, and then that could potentially change the state that you're in. So that's the transitions. You transition from one state to another based on an associated event, a button press, some sort of AI input, looking to see where the player is. If it's close, do something. If it transitions to some other state, if it's far, transition to a different state. That's the basic idea of the finite state machine, and that is something that we are going to code up today. We're doing this in the OOP way, but you may see, and you may have used something like this before, but used enums instead. Enums are very common. Even in the sort of the OOP way, we still use enums. They're just not the main sort of state thing. If you've never used enums before, that's perfectly fine. We're going to use a couple today, but you'll sort of see how they work from that. But depending on the complexity of your of the states that you need, enums may work, but they may not. I typically shy away from them nowadays. So previously in sort of my sort of game programming life, I use them to control game state, but you do eventually run into the same problem that we saw earlier. You end up with a whole bunch of enum, or you end up with one enum with a whole bunch of different values that you have a bunch of if statements all throughout your code that access this enum to check what's going on. So for a relatively small set of states, enums can be good, but as soon as things start to grow, enums are not scalable either. You start to run into the same problem you did with using just Booleans from the example previously.
So is that the reason why you don't use interfaces? I know last time we used like the public abstract class instead of an interface. Is that kind of like the reasoning why?
I do, if I'm not using Unity, I do use interfaces a lot more. The main reason is Unity doesn't allow you. I can probably show you in Unity when we jump in, but if I created a public, and then whatever the type is, so last time we did like factory. If I had an interface instead of an abstract class for factory, like last time, if I said public factory and then a name like my factory or something, if factory is an interface, it actually isn't serializable. It actually can't show up in the inspector. So then I can't drag something in there to sort of be the factory, to represent that factory. I would have to manually, in the code, I'd have to manually create a new specific concrete factory type object and stuff. So in Unity, I tend to shy away from them a little more because I can't do inspector stuff with them. Otherwise, in something like Java, if I was making a factory pattern in Java, for instance, I would 100% use an interface for the factory and for the product and for a few other things in the factory pattern. But it's mainly just because Unity can't. The terminology would be Unity can't serialize interfaces.
Okay, thank you.
Yep. All right, so the general idea with what we're going to code here in just a moment is we're going to create an abstract state class. It's not going to be a mono behavior. That's going to be one of the other key pieces here. We're not going to attach this state class to a game object. In principle, we could, but I'm going to show you sort of how we're going to actually use it after we finish coding it up. So we're going to create this abstract state class, and it's going to have information about the possible states. Those are going to be enums. And it's going to have 3 state-related methods. The subclasses are going to override those state-related methods. So again, we'll talk about that in a second. And then we're going to have a method called process. So we're going to essentially sort of process the state machine, process what happens during this sort of iteration of the game. And we're going to create a specific state subclass, so a child class, that only overrides the methods from state. And we're going to have one child class for every state that we want. So let's think about that a second. Let's say we want to control overall game state. And we have a play state for our game where the user's playing it. And we have a game over state, or maybe a game where like a score is displayed or something after you lose. So we would have the state class as abstract, and we would have 2 child classes, the play class and the game over class. So that's the way I want you to think of this. We have some abstract class, and then for every state that we want, for this state machine to represent, there's one additional class. So for our sort of diagram above, let me go back a couple of slides. For our diagram above, here we would have 5 classes. Our overall state class and the 4 possible states that we're going to create. Now, it seems like a lot, but each of these classes are relatively small. And part of the reason for that, and this is kind of subclass sandboxy thing that we talked about last time. Not exactly, but it's pretty close, because really what we're doing is each subclass is going to have these 3 methods that potentially do something slightly different for each of the classes. So there'll be an enter method, which is what happens when we enter the state. Do we need to set anything up for this state to work properly? We'll have an update state, or an update function, which is what happens when we are in the state. and we have an exit function, which is what happens if we leave the state. Now, for the example we do today, I'm going to put some prints in here so we can see what's happening and how the states are changing. But in your real game, you might have stuff to set up when you enter a state. You might need to create some variables and maybe get some information from, I don't know, who knows, a spawn manager or something. For update, you might be checking for keyboard input. You might be spawning more enemies. You might be doing any number of things while you are in a particular state. And then when you exit, that might be cleaning stuff up, maybe resetting some stuff. For example, if I was in a game over state, when I leave that game over state, maybe to go back to the play state, exit would probably reset the player and the enemies and the score and all that other kind of stuff. So it's what happens when we enter, what happens when we're in the state, and what happens when we exit the state, when we leave the state to go somewhere else. The somewhere else where we go, that's one of the interesting things here. And that's one of the things that sort of keeps us in that sort of state pattern idea that we're going to show. So I know right now, you might be very confused. You might be like, okay, well, this all sort of sounds good. It's this sort of academic sort of sounds good type of thing, but how do we actually do it? And I know in a lot of classes, I don't know about some of the other sort of junior level CS classes, but I know that in a lot of classes, this would be where and especially classes that I had, especially in like physics and stuff, this would be where the professor stopped and was like, all right, so your next homework is going to be to code one of these up. And then you're just going, well, I mean, it sounds good, but I have no clue. So we are going to make one of these today. And like I said, we're going to make them in the next 2 games as well. Because what I want to focus on for these design patterns is not sort of the theory behind why they're good or why they're bad and all that sort of stuff. I want you to be able to take this and use it in a game that you want to create, because they're useful. They're not just for that sort of academic stuff. So a lot of the next few slides are showing some of the code and having some pop-ups and stuff about what's going on. So I am going to show some of this rather than just go jump into Unity, but we will jump into Unity and just code all of this up. So I can sort of have a second time to sort of talk about it and sort of after going over some of the pop-ups and stuff. So this right here is not the full class for the abstract state class, but this is the first class that we're going to write. So this is state, and it's just an abstract class. It does not inherit mono behavior. So again, we cannot attach this to a game object. It's an abstract class, so I can never create one of these. I can never say, whatever, state s equals new state. I can never do that. But we will create new states based on our concrete state classes. We have 2 enums. You can name these enums kind of whatever you want, but the first one contains all of your states. And I think actually my pop-ups are probably better for this. So the state enum, so what I've named state here, like all caps state, it contains all the possible states for that machine. So we're going to create a state machine with 2 states. If you needed more, you could just easily add more in here. If you want to do different type of stuff, this is sort of meant for a overall sort of game controller finite state machine. But if you had an AI state machine, you could have idle, an attack, a chase. Another state might be like enrage or something. Like you could have tons of states based on whatever you want the AI to be able to do. This event is the possible events that can happen when you are in a state. There's only ever 3 of these. You can enter, update, and exit. So remember what I said. Enter is when you come into the state, update is when you are in the state, and exit is when you leave the state. So essentially, for each state we have 3 events that can possibly happen. And then enums, if you've never used enums before, they're actually kind of like simple classes. So we actually do need to create variables for them. So that's what I do. Yeah, so the pop-up's not entirely useful. I create a variable of type state, so it's one of either play or game over, called name. I create an event called stage. I've seen this called lots of other things, so I just call it stage, but really it's up to you. And you find an implementation where you like the name better or it makes more sense, but kind of think of it as this is the stage you are in in that state. So you're in the enter stage or the update stage or the exit stage. So that's why I call it stage. So that's going to be one of these three things. And then I also have a variable here called next state, which is a state variable. You'll see where this is used, but I don't think it'll make a whole lot of sense as to why it's needed until after we get the whole thing coded up. Joey, why are they protected? Yeah, so the state name here, this could probably be protected too. I'm not exactly sure why I have this public in here. It could probably just be protected as well. Remember that protected means that the child classes can access them. And of course, in the same class can access them, but no one else can. So it's our sort of private for our sort of inheritance hierarchy. So they're not going to be able. You can't access them from outside, which is sort of that whole sort of encapsulation purpose. But the child classes will need to access them 100%. The child classes are actually going to change these values, and this, like I said, this can probably be protected as well. I don't think. Just thinking of what the rest of the code looks like, I don't think this needs to be public. I suppose you could access from outside to know what state you're in, but Unity has an easy way to check what actual class you are. So it's probably not necessary to be public. We have a constructor as well. For now, it's not going to do anything. It's just going to be empty. You could put a reference in here to like a game manager or something. That's perfectly reasonable to do. Some sort of you have your game manager GM equals game manager.instance. That's a reasonable thing to do. So you can add anything else you need to this class as well. It's not like you have to only have this stuff. If you need other stuff in here for your state machine to work properly, throw it in. What I'm basically showing you here is the sort of minimum possible stuff that you need for this to work. Okay, so that's the beginning of the class, but like I said, this is not all the class. Then we have some functions. So these are those functions I talked about. They're virtual. If you remember for C#, virtual means it can be overridden. In Java, you didn't need something like this. In Java, didn't matter. If you wanted to override something, you just did it. Override something from a base class, you just did it. In C#, we need the virtual keyword to denote that it can be overridden because we will override it. So we have enter, update, exit. And I think I'm going to pop up here. Yeah, it just says these are overridden. The base versions are here. We actually will be calling the base versions. So that is an interesting thing. And you might see this and think, is this a typo? Because here I've got update has event.update. Exit has event.exit. Why does enter have event.update? Why isn't this event.enter? Is that a typo? No, it's not. So as we go through and sort of code it up, you will see why it's not an actual typo there. And I think I may have mentioned something about it in here. Yeah. Okay, and then here's our process. So this is the process function. It's not meant to be overridden, so it does not have virtual in here. So this will be run. This version will always be run. This is the heart of our state machine. This is where the magic happens. Process changes the state based on the current event. That's what's happening here. So let's think about it for a second. When I run process, whatever state I'm in, it actually doesn't matter here. Whatever state I'm in, we're going to check the stage we are at within that state. If we're in the enter stage, then we're going to run the enter function. That should make sense. If we're in a state and we're in the enter stage, we should run the enter function. What does the enter function do? It's going to do whatever you need it to do in the subclass, but it needs to do this. Because you're only going to do the thing for enter one time. You're going to run whatever is in enter once, and then you're going to get to update. That's why this is event.update. Because after we do this, we can actually run an update. So we do enter, and then we immediately do start the first update. So if we're in the update stage, we run the update function. Well, what does the update function do? It keeps us in update. So the next time process runs, we're not going to be in enter, we're going to be in update again, and we'll run update. And then when process runs again, we're still in update. And process runs again, we're still in update. Now I want you to think about when process should be run in Unity. Update sounds pretty similar to our update function in our mono behaviors. That's where we're going to call process. Process is going to run every frame. So that means update will run every frame. Yeah, so Joy, does a way for keyboard input? It can. We're going to put keyboard input in the implementation that we write. So process is going to run every frame. It's going to run update every frame. Then at some point, maybe keyboard input, update is going to say, where our own version of update is going to say, we need to exit. We need to change states. And that could be based on anything. I said it could be based on keyboard input. It could be based on distance to a player, distance to an enemy, the level you're on in a game. It doesn't matter. It could be anything. Then we're going to trigger exit. We're going to say, we need to go to the exit stage. When we do that, what happens? Well, it immediately goes to here. And it says, we're in the exit stage now. We're going to run exit. And we're going to return next state. Notice, this function returns a state. It's going to return the next state, the state that we're going to. So when we exit, we're going to go to a new state that is determined by this next state value. Otherwise, if we don't return next state, we're always going to return this. Why is it this? Because that's the state we're currently in. We don't change state. If we're in update, we don't change state, so we just return this every time the process runs. Okay, we're going to go in and code this up. I know it still might be confusing right now. Until you see the classes, the play and the game over class, it might start making a little more sense at that point. But I'm going to code this piece up right now, this sort of state class right now. So I'll sort of talk a little bit more about each of those individual parts. So actually, let's turn this product system off here. It's so pretty, it's a little distracting. Okay, so I'm going to delete update and start. We don't need it. And I'm going to delete mono behavior. So we've got a public class. This needs to be an abstract class. All right, so the first piece of this, the first thing that I threw in there was the enums. So we're going to have a public enum, and this is going to be called state. So again, this is any of the states that I want to be part of this state machine. So it's possible you might have multiple state machines in your game. You might have a state machine for bosses. You might have a state machine for melee enemies and ranged enemies and game state like we're writing now. And you might have lots and lots of different state machines in your game. Each of them would have their own separate possible states. So we're going to have play and game over. And we'll create that other one that I think I called it event. So this is going to be that stage that we're in. So the order here doesn't really matter. We're not using the order for any sort of particular reason. I don't have them ordered for any particular reason. So exits, so I guess I kind of have these backwards. Exit, update, and enter. So those are my two enums. This will always be the same in your state class. The one that'll be different here is the possible states that you could have. And then I just have the variables here. I'm gonna leave this one public. Actually, let's just make this one protected as well. So this will be a protected state. I'm just going to call it lowercase state. This. Oh, the suggested name, that's funny. It's lowercase s and then capital rest. And then I'll make a protected event called stage. And then I'll make a protected state class called next state. The sort of name here might be a little bit, you may name this something else or something. You may name this something slightly different. So I don't have a state and a state and a state, 3 different state variables here with different capitalization. Might be useful to do, may make things more clear for your own projects. And then finally, we just have our public state. So our constructor doesn't do anything. Again, you may have it do something. Whatever you need it to do, whatever all of the state classes eventually need, you could put them in here. Again, this is sort of minimum possible stuff that you need for the implementation that I'm showing you. Next, the next stuff we talked about on the slides were the different functions. So we're going to have public virtual, void, enter, and this will be stage. So we're going to change the stage to event dot update. And I'm going to copy and paste these. So I'm going to have updates and exit. And the only different one here is this one. So it's the same ones from the slide. Again, they're all public virtual void, enter, update, exit. And for enter and update, the stage is the same. And for exit, the stage is exit. And then the heart of the actual state machine itself, the process. So public state, process. 3 ifs. If the stage is equal to event dot enter, then we're just going to run enter. If the stage is equal to event.update, we're going to run update. And if stage is equal to event.exit, that's when we do some more stuff. We are, that's that one. We're going to run exit. And we're going to say return next state. Otherwise, we're going to return this. So this this means this state. This needs to be stage. I know that this can look confusing, but just keep in mind, when we are at the enter stage, we run enter. That will change our stage to update. So we only run enter once. When we're in update stage, we always run update. When we're in the exit stage, we run exit and we return a new state, whatever the next state happens to be. If we're in update, though, we will always just return the same state, this. That's what's happening in this process. All right. Further questions? You have further questions on this? This process is the heart of the state machine. When you see the play and the game over, all that defines is enter, update, and exit. That's all it's going to actually define. So we'll define sort of what happens in those states, what triggers these different stages from changing. Yeah, so when is this method called? Joey, you're talking about the process method? This will be called, for our particular case, process will be called in our game manager. We can actually do that right now. We actually need one of our concrete states first, but I can sort of outline it here for you. So I'm going to create a new script. So I'll create a new C# script, and I'm going to call this one Game Manager. So it's our standard Game Manager thing. I can create an empty and drag the Game Manager onto that. So we have our Game Manager script attached to some empty game object. if I open up the game manager, we're going to call process right here. It's going to run every frame. In order to do that, I need a concrete class, because we're going to have something like this. We're going to say whatever public or private state, game state. But I need a concrete class first. So I can say game state equals new whatever, play. Right now it's not letting me do the autocomplete easily on it because play does not exist yet. That's how we're going to set up the game, game manager. So in here, this will say game state dot process. And in fact, we actually need a little bit more to that line, but for now, this hopefully makes a little bit more sense as to what process is actually going to be doing. We have a state. That state is going to be, it's going to start in the play state, and then we're going to run process every frame. So we still need that line to work for us. In principle, you would probably put a bunch of these state files like in their own folder or something. I have used it before in like actual sort of like production type games where everything's all in the same file. It can get a little bit cluttered as you get more and more states. Then you're scrolling through potentially hundreds of lines of states before you find the one you need to find. For now, so that everything's all compact and so I don't have to constantly switch between files, I'm going to keep all of these classes, these state-related classes, in the same file. But sort of for an actual game, you might want to have just a separate folder that you're saying, this is boss 1 state machine, and they're all in one folder. This is boss 2 state machine, and they're all in one folder. So after all the brackets, I'm going to create a public class called play, and this is going to inherit from state. So that's my class. Same thing for game over, and we'll fill these in a second. We're actually going to go back to the slides first. So class game over, going to inherit from state. So every single thing that I have inside of the state enum is going to be its own class as well. These will be the concrete classes that we create. So let me go back over to the slides. And we'll get down to this one. All right. So here's the concrete play class. We haven't talked about regular classes much. We had the little sort of review thing at the beginning of the semester, or sort of C# for sort of beginning C# for Java folks. We're going to have the constructor first. This here, so the name of the constructor and then :base, is the equivalent of Java needing the first line in your constructor to be a call to either this or the super constructor, the superclass constructor. So this is that equivalent thing. So if you're wondering sort of, well, why is there a :base here? This is the call to state's constructor. State's constructor takes no arguments, so I don't need any arguments in here. But I do need to have this in here. When you go into the state, or when you construct a play class, I set the name of that class, or the state of that class to state.play, and I set the stage to enter. So if you want to go into a play class that you've just created, if I create a new play class, it's going to start with enter, and the name is going to be play. So in the constructor, I do set a couple of things. And hopefully this makes sense. The name is just a label. This is state.play. And the stage is the enter stage. If I come into this class, we should be at the enter stage. Not in the update, not in the exit, but the enter stage to start with. Notice what the enter does. It just calls base.enter. So that's in Java, that'd be equivalent of calling super.enter. We do have the override keyword, so that is necessary. It just calls it base.enter. Remember what base.enter does. it changes the stage to update. If I need to do anything important in enter, like setting up some variables, maybe you could reset players here. You might do that in the game over exit stage, but you could do it in the play enter stage if you wanted to as well. You might reset players, reset score, print something out to the screen, whatever you want to do in enter. And in our example, we will be printing stuff in here. But to keep the stuff on the slides as compact as possible, I just left it as enter. We're also going to write update. This is where the important stuff happens. This is where you'd have a check. If something is true, whatever it happens to be, if there's a keyboard press, whatever, it doesn't matter. This is the trigger to leave the state. So in the example from previously in the slides, if you press the B button while you were standing, if you were in the standing state, then your if would be if you just press the B button. Then you would go stage exit. I only have one connection in this diagram. If you exit the play state, the next state is a new game over state. And then we call base.exit. Remember what base.exit does. It sets our stage to exit so that we call all the appropriate stuff just to set our stage to all the next stuff we need to do for that ifs in process. So the next state is a new game over state. This is what's going to change our class. So that's what changes our class, and we're going to see that here in just a second. So I'm going to add some prints to this, and then we're going to actually run it. And this is it. This is the entire play class. So there isn't anything more to this. And I think I have a few pop-ups here. Things like constructor sets the name. If something equals true, set the stage to exit, and then by setting next state to what gets this is what gets returned from process. So let's go in and make that real quick, and then hopefully by putting these two things together and seeing them actually work, hopefully this starts to click for folks. So for our play class, we're going to start with the constructor. So public play, play, and I need the call to base. And we'll set the name. And again, I don't think I actually used the name here, like at all. I think, yeah, that's still up the name. Oh, did I call this something? What did I call it differently here? Let me take a look at the slides here. I think I called something different here, and that's screwed up a little bit. Yeah, so the state enum I called name here. So let's go ahead and do that. So back up here, the state enum I called name. Sort of the name of the state. All right, so name, this is just going to be state.play. State.play. And the stage that we come into when we create one of these classes is going to be the event.enter. So that's our constructor. Whenever we create a new play object, the name is set to play, the stage is set to enter. Then we need the three functions. So this will always be public override. I think these VS Code, I don't know about some of the other ones, but I think if I start typing enter like this, it fills stuff in for me. So I start typing enter, we need enter, and this is an automatic call to base.enter, and that's actually all we need for this at the moment. Again, I will put a print in here, though, in just a second. We need the other ones as well. So public override, void, we need update. This is where we're going to put some of the interesting stuff. And then, of course, we need the override, void, exit. All right, so we just have a few things to edit in here. I'm not going to call base.update. I'm going to leave that out because we got some other stuff to do here. So I'm going to say if. Let's do some keyboard input. Let's do what Joey mentioned. In update, we're going to look for some keyboard input. I still have access, even though this isn't a mono behavior, I still have access to all of the Unity engine stuff. So I'm not restricted to just generic C# things. I can't attach this to a game object. So I'm never going to say this dot get component and all of that. Never going to do any of that stuff. But I still have access to all of the other sort of regular Unity stuff. So I can say if input dot get key down, and then we can say key code dot space. Let's say space. So if the user presses space, if we're in the update phase, update stage of this state, if we press spacebar, then let's do stage equals events dot exit. So we'll exit this state, and we're just going to, in this case, I'm just going to return. So we're going to exit the state if we press spacebar. Well, what should that do? That should immediately run this. So I'm going to say next state equals a new game over. Now, we obviously haven't coded game over yet, but I want to throw a few prints in here. So when we enter, so I'm going to say we don't have access. I don't think we have access to print. Yeah, so we do have to use debug.log to print in here. I'm not sure why we don't have access to print. It might be. I actually don't know for sure. It must just be a monobehavior function then. That's only a monobehavior, not part of the actual library. So in here, I'm going to say entering play state. So we'll see some prints that happen here. In here, I'm going to say updating play state. I'll put one in here as well. So we can say space triggers exit play state. And then here I can say exiting play state. So just a few prints. We'll comment some of them out because this is really going to flood our console. But what you'll see is that when the program starts, it'll print once saying entering play state. Then it'll print a whole bunch of times saying updating play state. Then I press spacebar and it will say space triggers exit play state. Then it will print exiting play state. And then our class is going to appear to change. So we're about to see that happen here. So let me make sure that's saved. And actually, I need to go to the game over thing here, or the game manager. So a game manager class, we can now do this. That should work just fine. We're still missing something that's going to have the class appear to change, but I do want to show you what the class, what we can actually do here. So I can to see what the class is. So I can say print. This should be game state, if I remember correctly, dot get type. There we go. So that's going to get the type. So that's actually going to tell me this is the play type. So we will look at that here in just a second. Once we do some running, we'll put another one of those prints in. So I'm basically going to start it and then pause it real quick. Once we get some prints. Okay. So I have the game paused. Yeah, I'm going to increase the size of this. So the first print here is play. That's our print game state get type. So we know that game state is of type play. That should make sense. So we just made it in start. Awesome. The next thing that prints is entering play state. Hopefully that makes sense too. Because remember, in play, our stage starts at enter. So the first time we run process, we have a play state running process. If the stage is enter, we're going to run the enter function. This gets into the stuff you saw in the stuff you sort of started learning in CS2 with the dynamic binding and all of that. What enter does it run? Not this one. It runs this enter. So that's why it print. And then I also did run the base.enter. So we did the print, and then I run the base version, which changes the stage to update. All of that time, we're still in process. We're still here. So after enter runs, we're at event.update. So the next if triggers. Now we run update. So we come down here to update. We run this version of update. It says updating play state. It checks. Was the space down? No, it wasn't. I didn't press anything. And so update just ends. So update's over. We are not in the exit stage, so we skip this and we return this. That's what I'm missing from my game manager. I didn't catch anything here. I am returning a game state, but I didn't catch it. So let's put that in. Game state equals. So I returned this from running process. Well, what is this? It's my object play. So now I'm going to run the object play again, process. So I go into process. I'm still in my update. So I run update, which does what? Prints out updating play state. Skips over this because I didn't press any keys. This is like the second frame update of the game. Exits out. Doesn't change the state, so we skip over this piece, returns this. So this is constantly, as we just ran it, this is constantly returning the play object. It's returning this back to here. Running, return, running, return, running, return. But if I press the space bar, so I'm going to unpause this as long as we don't get any like warnings or errors or something. I'm going to unpause. I'm going to yeah. If you go in and mess around with the code while you're playing and it recompiles, it does cause problems. So I'm going to do this here. I'm going to press space and pause. So we are getting some errors. That's because I haven't written game over yet. So this is where it happened. Space triggers exit play state. So this time, during that update of the play state, so during the play state update, it saw that the space was down. So I press the space bar. It triggers the exit. It sets my stage to exit, and we return. So now what happens? We just ran this, but now my stage is exit. So it's going to run this right after. So it runs exit, but what exit does it run? Not this one. It runs my exit down here. So then it should print exiting play state, set the next state to a new game over. And then it runs this exit, which is actually redundant. I don't actually need to run based.exit. Typically, I'll leave it in there, but I don't actually need to because the only thing based.exit does up here is it just sets the stage to exit, which it already is. So it is redundant here. So we say exiting play state, and we're no longer in this state. So we're basically done with our state stuff at that point. And that's what happens here. And I think this is the game over doesn't have any of that stuff in it, so it's so that's why it gives me some errors. So you see the exiting play state. So process being in here. So process being in update means that I've effectively shifted the entire update process, the entire update of my game to this one. Whatever state I'm in controls what update does. I hope that sounds powerful. Think if I had a pause state. In my regular play state, you might be spawning enemies. You might allow for keyboard presses to fire bullets from a spaceship or something. If you're in a pause state, you can just not have that stuff happen in your update stage. And then the game is effectively paused. If nothing is spawning, nothing is moving, you can't shoot, you can't press any buttons other than maybe a menu screen that pops up. You've effectively made a pause without actually doing much of anything. You just created an extra state that didn't have anything in update. That's powerful. That makes a pause or a quit or a game over state very easy to deal with. You don't have to check in all your game objects. Is the player dead? If it's not, then do normal stuff. If it is, then just return. You don't have to put that stuff in there because the state takes care of it, which is actually really cool. Let's put in the game over one. It's going to be basically the same. except let's see, yeah, it's gonna be basically the same. We might make a couple changes to it from what I had before, or from what I have in the slides, but we will probably add some more prints and stuff like that to it. All right, so where are we here? All right. When it comes to play, there's nothing special happening here. Update is just going to run every frame. If you're actually in a game, you might spawn, you might move, you might update the GUI. Anything you need to can happen in that update function. Any code that needs to be set up before update can happen in enter. Similarly, anything that needs to be cleaned up can happen in exit, because those things are only going to happen once, at the beginning and at the end of coming into the stage and leaving the stage. All right, so game over. This one is not going to be too complicated here. I don't have anything sort of extra in there. I may make it so we can switch back and forth between play and game over just by pressing the spacebar. But for the moment, this can just be very, very simple. So a lot of times, the base sort of version of the state classes look identical. It's just different things you're going to do with them once you have them. So I'm actually going to take most of this. And I know I always say to my, especially to my freshmen stuff, I always say if you're copying and pasting code, that usually means you could do it differently. But for these states, the reason why that is why that's useful is because the base state code is basically the same. So I'm gonna get rid of some of the prints here. We will keep, actually let's keep the one that was here. We'll say entering game over state.
Why do we use name on line 90?
Yeah, so this in C#, we don't actually need it. This could be, if this was public, which is probably why I had it public in the slides, then you could access the name very easily. So in our game manager, instead of me using a function that's sort of built into C#, I could say game state dot name. So if I wanted to know what state I was in, if I wanted to print out the state that I was currently in, then I could just grab the name like that. So that I think that this is more of a convenience thing to have name in there. But if you have something like a type of like C# does, then name is basically redundant in that case. Yeah, so game over. So we'll do something like that. Let's have space trigger exits game over state, and then here, instead of the next state being game over, we're going to have the next state be play. So we're going to be able to switch back and forth. Have an extra bracket somewhere. Instead of having game over state just not do anything and not be able to change, we're going to have it so if we press space, we go back to the play state. So we're going to be able to swap between play and game over. And again, so we're not spammed so much in the console. I got rid of the print that was here, and I'll get rid of the print that was up here as well for updating play state. But keep in mind that update function, no matter what state you're in, the update function will run every frame. So if I switch to game over state, then the game over one is running every single frame. And so in here, in these functions, you might have something where you display actually, it would probably happen in enter. In enter, you might display the game over GUI. And then in here, you might be waiting for a key press. For key to restart. And then in here might be reset, spawner, and player. Whatever sort of needs to happen in your game one time at the beginning of when you first hit game over, and then when you're leaving game over. What needs to happen in those cases? So this could be waiting for a mouse click, waiting for a button click. Yeah, it could be one of any number of things. Okay, so that should be okay there. And here we'll keep that as it is, and we'll always do the game over stuff. And we'll see if we get those errors again. We shouldn't, but never know. So let's just check that, clear this out. And run it again. So we should just see a couple prints. So the state that we are is play. We're entering the play state. We're in the updated play state right now. If I press spacebar, the game, then space triggers exit play state. We exit the play state, and now we enter the game over state. I press spacebar again. We exit the game over state, enter the play state. or exiting play state, which I probably just didn't change the name on that, and then entering play state. Let me check that here. Yeah, this needs to be exiting game over state. I'll do it one more time, and then I'll show you that sort of magical thing that it looks like a class is changed, an object is changing its class over time. So here's the thing. So entering play state, space triggered the exit, we exit. Entering the game over state, space triggered the exit of game over, exiting game over, entering play. So as many times as I press spacebar, we're going to constantly switch between game over and play state. And again, this is where stuff is happening in your game. So if you had a pause function, it could work almost identically to this. You press the pause key. I probably have a pause key somewhere on the keyboard. You press a pause key, you go into the pause state. Now nothing is updated. You're not checking for user input for firing a weapon or moving your character. You're not checking for spawning of enemies. You're not doing any of that stuff, so none of it happens. And so you've effectively paused the game with only writing a little bit of code to create a pause state, only writing probably about this much code. Now that sort of magical thing that I mentioned is it is going to spam our console a little bit, but I'm going to do another print of the type. Print GameState.getType. It's play here. But whenever we press spacebar, this is going to change. So the type of GameState, the object GameState, is going to appear to change its class every time I press the spacebar. So we'll stop the game. And it is going to spam the console, so we'll have to scroll back a little bit, but I'll press spacebar a few times. I'll pause it, go back up to the top. So here we were in play. I'm still printing out some of the sort of entering play state and all that kind of stuff. So play was the class that we are. Entering the play state, and so you see the play printing out a few times for sort of whenever it prints for the updates. And then space triggers exit play state. We're exiting play state. Now what is our class? What is our type of our game state object? It's now game over. And we have the entering game over state and all that. And then next time I press space, we're back to play, because that's what our class looks like now. So that's one of these, and to me, this is one of those cool things. I know that it might be a little sort of nerdy to think, oh, cool, object is changing its class, but that is what's happening here. The object appears to change its class. It's not really. We're creating new play and new game over every time we switch states. But from the outside, if you're standing outside of this state machine, it looks like when the user does something specific, like presses a pause button, it looks like the class changes. And now something totally different is happening. Even though from the outside, it looks like all you did was press a button. Now all this machinery caused the class to change. All that machinery is just a little bit of cleverness underneath the hood here. And for the most part, it's just this is the cleverness. I don't expect everyone to fully understand this. The first time I sort of saw this sort of stuff and sort of read about state machines and sort of coded one up for the first time, I was like, I coded it up sort of following the sort of information that was given. So kind of like if you coded it up just following the slides that I had. But you're still like, I don't really understand. I don't really get why this works the way it works. That's okay. That's exactly how I felt the first time as well. So if you have a little trouble with it, play around with it. Throw a few more prints in. See if you can fully understand why this is working the way it is. And maybe code up a little bit extra, and have it be like have something happen with a player game object or something. Code up something where you have user input and try to do that little pause thing that I mentioned. Try to have a pause state and a play state. You move around, you move some character like our snowman with the arrow keys. You press spacebar, it pauses. Check that you can't move the character with the arrow keys anymore. See if you can get that state to work properly for a little sort of dumb test game, because then that opens up the possibility for using this in much more complicated things. As soon as you see how it works, as soon as that clicks and you understand, oh, that's how this works, then it opens up this huge possibility of as many states as you want and using it for AI and all kinds of other stuff. Now, again, we're not going to stop here. we are going to use this in both of the remaining games. So you will see more of this. And that's the point of why I wanted to include it. So it's not just a single lecture and then you forget about it a week from now, that we actually use it to do something. And hopefully it starts to click, sort of as we use it a bit more and more. So let me go back to slides real quick. I think there's not a whole lot left here. Yeah. So we basically coded up sort of as we went along. In our next game, we are going to use this, and then we are going to use it in our third game as well. So we got about 10 minutes left. We're basically done. I want to give one more chance here. Does anyone have any questions they want to ask right now about this state machine?
So would we use this on like a player? Like would we attach it to like a player to constantly kind of check for like a key input, and then we move the player associated to that? Like on enter, we do something to the player. And
If the player has a state, so if the player like the example from the slides in the beginning, right? If the player has some kind of state, let's see up here, yeah. So if the player has states associated with what they can do, then you would do something very similar that we did with the game manager. So the player, so if this was a player class instead of a game manager class, I would do something similar. I would say something like I would create exactly the same thing like this, and then maybe I would have a standing state. So I would say this is a new standing. So when the player gets spawned, they're in a standing state. And then I would have this as well. This would be exactly the same thing. So I'd have the standing state and I'd have the process. That process, the process here, it's still exactly the same. It's the state is the actual abstract class is exactly the same. It's in here in the update that would be different. So I might have something like if and I may have a function or something that I can use. So I might have something like player dot get inputs. Obviously, I don't have a player class. Something like gets inputs. So I might have a class that I use here. I need a reference to the player, so that might be something I need for a player state machine. I get something like if player dot get inputs, then do whatever if this equals true. So there was some input, then I would do something like do whatever sort of input needs to happen.
now, how would you handle like let's say a collision? Like let's take an example like the fireball in Volcano Island. If we
Yep.
get hit by the fireball, like we would attach like the movements to and like ducking to the snowman, and then let's say he gets hit. Would getting hit trigger? It would be in a different kind of thing. It wouldn't be in like the state, right?
Yep. Yep. So that would still use our like on trigger enter.
Yeah, like a particle system, like kind of
Yes, we had our on trigger enter, and we could run the particle system from on trigger enter. Everything doesn't have to happen here. That is one of the keys. That is one of the things to remember. You don't have to do everything in the update for the state. This should be only related to the state itself. So if we move, for example, this may not be get any input. This might be just checking if player.getInput equals down, pressing the down button. Then you might have something where you change your stage. Say change the stage to exit, and you might set next state here. You might set next state to to a new duck. So you might set it like this. You may not have this in exit, for example. You might have it in update. So you say that, okay, if the player pressed down, then we need to exit this state, and the next state is going to be the ducking state. So state-related things should go in here. But other stuff like collisions can still be handled by either the player object or by in our sort of Volcano Island, the fireballs. So state-related things do need to be dealt with in the update. So I know that it can still be sort of confusing, like what all do I put in here, but hopefully it will make more sense as we use it in the upcoming games. After we use it in Flappy Droid, we're not going to use it for much in Flappy Droid, just for the overall game state. So we'll have something like a play state, a game over state, a pause state, stuff like that. We're going to have that in Flappy Droid as the first example of where to use this. And then in the third game, we're going to use it for game state and for our boss AI. I don't think I use it for the regular enemy AI, but for the boss AI, where the boss could have different behaviors, we'll use this type of state machine as well, so you can see it in that context too. So I want you to keep this in the back of your mind. If you want to play around with what we did today, feel free to do that. And then if you want to see another perspective, a different explanation with with a different example, then take a look at the game programming pattern book, because he does not implement it in this way. You will see similarities, but it's not exactly the same. So I think seeing it from a couple perspectives can help solidify it as well. Okay, so that's pretty much all we have time for. So I will see you guys. Today's Thursday, yeah. So I'll see you guys next week. Have a good weekend.
Thank you,
Thanks,
Professor.
Professor.
Have
Have
a
a good
great
one.
day.
Yeah.
Professor, I just have a quick question. So for like the last, remember how we did like the screens? We were kind of moving back